Hello everyone, my name is Diego Bracho. I'm going to present to you briefly some of my work in polychromatic composite structures. So what is, first let's talk about photonic crystals. Photonic crystals are a periodic array of dielectric materials. These materials have a periodicity either in 1, 2, or 3 dimensions, and the periodicity lays within the range of the visible wavelength. So this periodic variation of the dielectric coefficient will rise into the formation of photonic band gap, which means that light will be selectively reflected or transmitted in the device, thus showing a color that it's a result of the structure of the material and not just an absorption of light as it is in dye molecules. So with colloidal self-assembly, we can create these photonic crystals in a solution containing a precursor of silica, which is a ceramic dielectric. And then by calcinating this material, we obtain just the inverse structure of this opal, of this three-dimensional structure. These show very angle-dependent coloration and this bright color characteristic of these devices. By tuning different parameters, physical parameters of these structures, we can change the color perceived of these materials. As I said, they have an angle-dependent coloration. They also, the color also will depend on the size or the lattice constant, the size of this structure, and on the refractive index contrast of the two faces. So far, we focused on lattice constant and refractive index change. So by changing the colloidal particle size, we can change the perceived color of the material, as well as also by infiltrating the structure with a solvent and changing thus the refractive index contrast, thus changing the color of the device. Future work will be mostly focused on the use of smart materials to be able to tune this visible spectrum. Thank you.